Okay, let's recall what is an EI user function. It is a function that data enter into our system, and then the data would be saved in an internal logical file, or perhaps database for that matter. Okay, so let's say, given this function, this example right here, you can see is being counted. So this is actually, I think here we said these are the kind of data input field, okay, or field in a GUI, okay. So you can see the counting 1, 2, 3, 4, 5, 6, 7, and this is 14th, and the OK button is also count as 1, okay, because it's invoking a function, okay. So but the cancel one is not doing anything, so that we doesn't need to count it. So you can see this EI user function has number of DET 15, okay, and let's look at what's the information being held here. It is the contact information, okay. It's contact information, so it's grouped together as like one group, okay. Occasionally you may have a user interface holding multiple group information. For example, sometimes if you are doing e-commerce ordering, a screen may hold the customer information as well as the order information. So in that case, you may have two groups, okay? But here it's all about contact information. So we group it together as one group. So now with 15 fields in one group, let's look up our table. So we find the right table, okay? So this is the EI table. 15, the column 15 is here, and only have one grouping, okay? Then it is barely considered low complexity. As long as the number of fields is added by 1, or the number of grouping is added by 1, then it will become average. So this function that we just saw would contribute to EI, okay? EI will just contribute 3 function points. So by adding up all the function points contribute by different functions, we have a unit to measure the complexity of our system. So as you can see, remember our earlier part, we said one advantage of using FPA is very objective. Objective, that means it does not depend on who is doing the counting or the calculation. As we can see, well, whether it's you or me, whoever is doing the counting, this is still 15, unless some of us overlook the field, okay? Otherwise, so this sort of things, we have a very systematic way of doing the counting, okay? And so far, any question? Okay, so this is a very nice question for exam, because it's very easy to mark, okay? That I guess as a teacher, we like this sort of test question, okay? And these links have some more examples you can go through. For example, this you can see So it says it has 4 data elements and 1 grouping. So 4 data elements. There's a social security number. There's a name, and there are 3 buttons. So looks like it should be 5, but somehow they said it's 4. I don't know why. Okay. So in this case, EI. Okay. I see why. Like here, they are not counting these buttons. Perhaps because each of these buttons correspond to a different function. So when you click on activities, it will show other data in here. Okay, so that means if we do that, if we count the button, then we may be kind of double counting. So the way they this come up with, so for example, this is external query or inquiry. So EQ is a query function, and the field that it has include 1 number, but actually the name consists of 3 separate fields. 1 is the last name, 1 is the first name, 1 is the middle initial. Okay， 西人嘅名係有個姓啦，就係 last name 啦，個 first name 啦，同埋咧通常係有個 middle name。咁 middle name 有即係個 middle name 咧，就好多時係用 initial。咁所以呢度咧，其實佢嘅名咧，佢係由3個咁樣組成一齊啦。咁你會話咧，咦？有冇機會唔同數法啊？咁我哋唔同嘅數法會唔會係當唔同咁樣？咁即係 will it be defeating our claimed benefit of being objective? Because we said FPA is good, is objective. Anyone do it, it's still the same. Well, it's still valid because it really depends on how it is stored in the data file or in the database. Because if in the database you only have 1 name field, then this will be 1, okay, for your program. But if your database holds 3 fields, then last name, middle name, and first name, then this will be considered 3 fields. So it's still sort of consistent with our original claim that FPA is an objective way of estimating the complexity. Okay. So this is a sample calculation. Okay, we assume that our system has 5 average complexity external inquiry and 2 high complexity external inquiry and 7 high complexity external outputs and 3 low external inquiries. Okay, so this is I like to use EQ. So because if we say EI, people may confuse with external inputs, and 9 average ones. So 3 low, 9 average, and 2 high ILF. So if these represent all the functions of our system, we can, based on this formula, for example, average EI is 4. Okay, we have 5, so it becomes 5 times 4. 2 high EI, so the value is 6 function points per high complexity EI, so we have 2 times 6, and 7 high EO. EO high is 7. This is 7 high EO times 7 function points for per high EO, and 3 low EQ. So each one is 3, so 3 times 3. 9 average EQ, so each one is 4 function points, so it's 9 average EQ times 4 function points per average EQ. And so 2 times 15 for ILF. Okay. And here, sometimes we see, for example, consider the ILF and EIF or ELF, EIF, okay? And you can see that EIF, for same complexity, has lower function points value, because that makes sense, because if it's an internal file, you have more to worry about, for example, updating it and so on. So this will result in slightly more function points, if so it makes sense. So it's based on people's sort of experience, that they figure out that so is this table, the value is not totally randomly, okay? So there may be a small degree of randomness, but basically they base this classification based on their experience. So FPA is still a very there's a lively community. So it's not like the OO measurement that we looked at. Is mostly history. So we are teaching it partly for historical reason, because people do not use it. But for function point analysis, some companies still use it, okay? And it's still being taught at other universities around the world, okay? So we see there's a mentioning of the word unadjusted FPs, okay? So that means there are 2 kinds of FPs. One is adjusted, but originally it was unadjusted. So what are the adjustments? Okay, so we have it's been identified 14 factors. Okay, these 14 factors, if it's not an issue, if it's not a problem, or it does not concern our system, then we would give it the rating of 0. Okay, if it's very highly influential, we'll give it 5, and then we can use 2 or 3 for like average impact. Okay, if these factors is a consideration of the system, because the other ones, the 5 user functions here, we only deal with functionality, right? But there are other factors that can make things more complex. For example, if it requires high performance, then of course high performance system will require more effort. Then you need to adjust it with some factors. So by having a maximum value of 5, you are increasing the amount. And if performance is not an issue, you may give 0. But of course, in reality, performance most likely would have 1, 2, or 3, or 4, something like that. Okay. Similarly, communication. If it's a standalone system, it will be easy, and we'll give it 0. But if it's highly communicative with other system, then we need to make it a 5. And so this is an example of one system, okay? So for each system, we may give it different rating, okay? But for this system, maybe we give this rating to this, and then give a 31. So I guess this adjustment part is where subjectivity would come in. So it may be possible that there's a small variation of subjectiveness, but it's still not too bad, because this is from the user requirements, right? Whether performance is important, or is it necessary to make it easy to operate, easy to install? If it's multi-site, then of course it can be higher. So how will these 31 affect the thing? Okay, but let me ask you, if everything, okay, at least theoretically, if everything is very important, what is the highest degree of inference we can get? What will be the highest? Well, it's 14 times 5, right? 14 times 5 is 70, okay? And what is the lowest? Well, the lowest will be 0 in all cases. So 0, so it ranged from 0 to 70. And we have a formula here, so that this is the technical complexity adjustment. Sort of assume that on the average, the degree of inference, is it degree of inference? Yeah, will be 0.35, because the largest possible value is 0.70, lowest is 0.0, then the midpoint is like 0.35, okay? So if it's the midpoint and adding it to 0.65, we will have 1. And in that case, there's, after adjustment, the number of function points will be the same. But this system we're working on right now has 31. That means it's lower than the 35 midpoint. That means this is a system on the simpler side. If there's another system with the DI being 50, then we would have 0.5, and then the TCA will be 0.65 plus 0.5, it will be 1.15. And if we multiply the TCA to the unadjusted FP, we get the adjusted FP. So in this case, the adjustment makes it lower. So after doing the adjustment, we say that this number of function points is a unit that we can estimate the effort to develop this system. Okay, and this slide shows how we are going to use function points. I'm giving you two examples. One example is, sorry, I created on Mac, and then when I gen the stuff on Windows, it is off a little bit. So to measure quality, we would measure defects, right? So that makes sense. But so let me ask you, if system A has twice the number of defects as system B, does it mean system B has better quality and system A has worse quality? Well, not necessary, because maybe system A is many times larger than system B. So even if system A has more defects, but if we take into consideration of the much more bigger system with system A, then the overall quality may still be better for system A. For example, if you look at a building in a small, in a large building, okay, if there's only one or two things you think is badly done, then it's not so bad. But if it's a small building, it also have one or two things bad, well, then it's very bad, right? So in that same way, we will do the adjustment, okay? So perhaps we can do the calculation by defects per function points. For example, maybe system B has 1,000 function points, okay? And system A has 3,000 function points. But let's say system A has 100 defects, and system B has 50 defects. So if we do some calculation, okay, so system A will have 100 defects over 3,000 function points. Okay, so the defects would be something like point. Let me do the other one first. So if system B, this will be easier. So it's 5 per 100. So that means it's 0.05 defects per function points. Okay, so this will have 0.05 defects, but in this case, the system A would have 0.033 defects per function point. Okay, so we can say, well, even though system A, this is system A with 100 defects, is actually, if we take into consideration of the number of function points it has, it's actually a better quality system. Okay, so this is how we do the calculation. And how about productivity? Productivity is I guess similar. Let's say if a team can create, a team of 5 people can create 10 function points per month, let's say. Another team create, well, actually, no. Right. So another team finish 5 function points per month, then we say this team A is twice as productive as team B. Okay, even though maybe team A takes many times longer than team B to finish their product, because maybe team A's product is bigger. Okay, it has 3,000 function points, while these other guys have only 1,000 function points on their project. So this we say this is like normalization based on the function points. And if you really want to, you can use that to compare productivity of persons. But sometimes this could mean if the employees may not be very happy. So you have to do the trade-off, because employees may not want to be compared. Okay, but of course you have some business reasons. So I guess it's business decisions often needs to be a trade-off. So let's sum up why function points is better. Well, for one thing, it is independent of the programming language. If you use line of code, 10 lines of Python do more work than 10 lines of Java. Okay, so you cannot just based on line of code if you're using different programming languages. And the thing with function points, you probably can do that with your design and analysis. So after your analysis, you will have the screen design, you'll have your data design. So you can have it during the requirements phase. So that's nice, okay? And it's very, with many, it has a standard way of doing things, okay? By this work group, this user group, okay? So there's an international function points user group with many thousands of members. So lots of people are using that, and also there may be some data out there to, even your company may be just starting to use function points. So for you, maybe you don't know how much work it is to do one function point. Well, you can use existing data to help you to figure that out. So people, the experience accumulated by other company can help you figure out how to make use of function points. Okay, how much work is actually one function point. So it's a very standard way of doing things. And of course, it's also a good way of negotiation. Okay, if you're negotiating with the developers how much you should be paying, then that function points may also be helpful too. And so it helps us to understand things better. But the function points is still, it takes time to learn to use function points. And the terminology may be a little bit old too. So still some amount of effort involved. Okay, even though you can reuse your result of your analysis. Okay, so adjustment factors may be a little bit subjective. Okay, and tool support, I'm not sure about tool support yet. Okay, so function points is very good. It helps us to adjust our comparison based on the system size, the project size. Okay, it has historical data to help us understand it, and also there are other estimation techniques we have not covered in this course. We don't have time, but you can at least you should know about the name. It's created by Barry Boehm, and a very famous software engineer researcher from U of Southern California. Okay, I'm not sure if he has retired. Maybe he's retired already. And there's another well-known method called COCOMO. Okay, COCOMO is another method. So so that's it for this chapter. So let's take a short break.